This meeting is being recorded.
In problem 814, we saw three reactions that had similar reagents in an acid-catalyzed hydration. So now with this problem, we reference that a similar mechanism will occur when a solvent of alcohol is used rather than water. So we're going to see a very similar mechanism, and we're asked to draw a mechanism for each of these reactions here. So we can see that it's acid catalyzed, definitely. But what we have here is methanol instead of water. And then our second reaction here, B, we're going to see an acyclic structure that can be become cyclic, and an intermolecular reaction, right? So one site might be slightly positive or an electrophilic center, and then the other site might be a nucleophilic center. So we'll see this intermolecular reaction. So let's take a look here with this first reaction, and instead of H and OH being added across our alkene double bond, we're going to add H and OCH3, right? So instead of OH, it's a little different because of the alcohol. So again, we're going to have our proton transfer. So here's instead of our, here's our methanol, right? Our methyl group. So we're going to have, right, this grabs this proton, this shifts those electrons. So we end up with our carbocation after our proton transfer. And then we have in step 2, the methanol that was created. So we have our OH and E. This serves as a nucleophile to perform a nucleophilic attack, right? So this attacks here, and then we have this that forms, right? And we have an extra hydrogen there. And our last step will be one more proton transfer, and that would be from another molecule of methanol. So this will grab that guy there. These electrons will go back here, and then we have our finished product that results. So I mentioned that the reactant in part B is acyclic. It does not have a ring, but our product is cyclic. So this was what's called a intramolecular reaction, right? The molecule reacted with itself. So we can see here, if we react this with H3O, so let's draw this here. Right, and we have our hydronium in solution. We can see that this pi bond grabs this proton. We have a proton transfer. So now we've created a carbocationic site over here. And we know that our OH is still over here. So this is an electrophilic center. This is a nucleophilic center, a nucleophile over here. And what happens is the molecule will react with itself. Let's see. Right, so this here will go reversibly to this form here. Right, so let's see if we can recreate this. This is my OH over here. This will remain positively charged for now. Okay, so this is the structure that would result. And if we take a water molecule here as our solvent, we can have one more proton transfer. And again, this step is also reversible. So we form our final product here as a result of that last proton transfer. But you can see that a nucleophilic site can react with an electrophilic site in an intermolecular reaction like B.